Okay, so now let's look at if we added a third factor to this polynomial. So let's say I multiply it by, let's say, just x, okay? And then we'll look at what y equals x looks like. So y equals x, I'll highlight it here, has a positive slope. So it has end behavior where it approaches infinity to the right and negative infinity to the left. So if we look at all four of these graphs together, all right, the green one being the product of the three, the green one has a negative end behavior as x approaches infinity, so this right here, because it's the product of a negative number times a positive number times a positive number, which would be a negative number. It has a positive end behavior to the left because it's a product of two negative numbers and a positive number, which is why it has a positive end behavior to the left, all right? As x approaches negative infinity, y approaches infinity. Now if we multiply that all out, as I did right here, all right, we see that there's a negative leading coefficient, which has to do with multiplying a positive x times a negative x times a positive x, right? Positive, negative is a negative. So that's going to give us the negative leading coefficient, which gives us the negative end behavior. So y approaches negative infinity as x approaches infinity. And it's going to go in the opposite direction because the degree is odd opposite, all right? And that had to do with, remember, on the right we had positive times negative, which gave us a negative. On the left, because this is the same continuous line, all right, we had positive times negative, which gave us a positive. All right, now, so that's one way to think about it, but there are rules that you can follow, and I could keep going on and on about this, showing you different cases, and so you see the pattern better. But the rules, when you want to look for the end behavior, is going to be to look at the leading coefficient first, and if it's positive, it's gonna rise to the right. So if we look at this picture on the left here, it has y approaches infinity as x approaches infinity. Same thing for an odd degree polynomial, but as long as the leading coefficient is positive. So the positive leading coefficient is going to tell you what's happening to the right, and then the degree is going to tell you what happens on the other side. So even, it's going to go in the same direction. Odd is going to go into opposite directions. Okay, and if we look at the other two cases that are possible, let's say we have a negative leading coefficient. Well, that's going to go towards negative infinity on the right, no matter what. If it's an even degree, it's going to go the same direction on the left. Odd degree, opposite. Okay, so I don't want to belabor end behavior too much, but let's just do two quick examples. So in number 4, we have d of x, and so first, make sure it's in standard form, which this is. And if you're looking for the end behavior, we're going to see that it has a negative leading coefficient. So that tells us as x approaches infinity, d of x approaches negative infinity. All right, and then we look to the degree. So the degree is the highest exponent of a variable, so that would be 10. All right, 10 is even, so that means it's going to go in the same direction on both sides. So if d of x approaches infinity on the right, it approaches infinity, oh wait, my bad, it approaches negative infinity on the right, so it's also going to approach negative infinity on the left. Okay? So if we were graphing it, we would start with that and then figure out what happens in between the end behaviors. Okay, for this example, e of x. Okay, so e of x has, it looks like a positive leading coefficient, but you make sure you put that in standard form. If you were to write this in standard form, negative 5x to the 13th would be the first term. So the leading coefficient would be negative. So as x approaches infinity, e of x approaches negative infinity, so it's going to go down to the right. And then since the degree is odd, it's going to go in the opposite direction to the left. So as x approaches negative infinity, e of x also approaches infinity. Okay, two other rules which I won't go into too much depth, but that go with graphing polynomials are that a polynomial of degree n has at most n minus 1 turns. So something degree 1 would be a line. So a line has no turns. It's just constantly increasing or constantly decreasing. N equals 2 would be a quadratic, all right? That has 1 turn. N equals 3. Now that could be, now I'm just drawing specific examples where it has a positive where y approaches positive infinity, but it could look something like this, where it has no turns, or it could maybe have up to 2 turns. Now, it's just a quick comment on this. If you think about it, those two things kind of go hand in hand with the turns. Like if this is an odd degree, it's got to go in opposite directions. So if it's approaching negative infinity to the left, then to the right it has to approach positive infinity, or else if it turned, then it'd be going in the same direction, so it wouldn't be even. All right, and that's why something with degree 2 would have to have at most 1 turn, because if it's approaching negative infinity to the left, then it's got to approach, if it's approaching positive infinity to the left, it's got to approach positive infinity to the right, which meaning it has to have at least 1 turn, or else they wouldn't be going in the same direction. All right, same thing with, so like in other words, like something with 3, degree 3 has to go in opposite directions. So if it had 3 turns, all right, 1 turn, 2 turns, 3 turns, it would be going in the same direction. All right, and from that, that's why now if I draw the set of axes on here, all right, you could see that something like a line that has no turns is going to have exactly 1, 0, at most 1, 0. Something like a quadratic could have 2 zeros, it could have 1, 0, or if that's the x-axis, it could have no 0. All right, and then same thing with cubics. Like it could just cross the x-axis once, or maybe 3 times. All right.